In section 3.6, we're going to be looking at what's called implicit differentiation. This is what you have to use when you really can't solve for y and you need to find dy dx. Now, let's talk about that for just a minute. That is the derivative of y with respect to the variable x. So, if we have, say, 2x, and I want to take the derivative of it, we're going to use that power rule like we've always done. We have 2, but it's really the derivative of x with respect to x. So as you look at that fraction, really, that's just a value of 1. So we're going to be differentiating equations that cannot be easily solved for y, but we still want to find dy dx. The idea is we're going to differentiate both sides of the equation with respect to x. And so the key thing is make sure that the derivative of any term, including y, involves that factor dy dx. And then we're going to solve for that dy dx. All right, so let's look at this equation. Now the rules are all the same. Going to use the power rule, quotient rule, product rule, all of that. Right? So let's say we have this term, so we use the power rule. So this is 4x. And since the variable is x with respect to x, plus this term, this would be 2y, dy dx, and then the derivative of a constant is 0. So taking the derivative is quite easy. Probably the harder steps will be to solve for dy dx. Right? So when we see dx dx, we know that's a value of 1. Right? So just algebra, we're going to isolate dy dx. So subtract 4x from both sides. Then I'm going to divide by 2y. Reduce that. That's your answer. This next one is just as easy because we just have the power rule involved. All right, so we're going to take the derivative of each term, but these two terms are the only ones that we will have that dy dx. So this is dx dx, the derivative of x with respect to the variable of x. Now, if you want to stop writing that, that's okay, but I'm going to continue. Then we have the next term. The derivative of y is 1, so we'd have 1 dy dx, and the derivative of 4 is 0. So that derivative is 0, that derivative is 0. All right, so now how do we start solving for dy dx? Well, I'm going to cancel that out, that's a 1. All right, so since these two terms have dy dx, I'm going to keep those. And I'm going to move the 3x squared to the other side, and of course it makes it negative. Now I can't start dividing because I've got to isolate dy dx. So I'm going to factor it out like a GCF. So that'll leave me 3y squared plus 1. Now I can divide both sides by 3y squared plus 1, and that will allow me to isolate dy dx. So this assignment is going to have not only the calculus, but the algebra.
This problem is a little bit different because we're going to have to use the product rule. This term right here is the product of two variables, x and y. And so in order to take the derivative, we're going to use the product rule. Because we know how to use the derivative of x squared, we know how to take the derivative of y squared, and we certainly know how to take the derivative of 10. So let's come to the side and use our product rule. You can put the 5 with the x or the y, it really doesn't matter. So as I take the derivative, this is going to be 5 dx dx, because the variable is x and we're deriving with respect to x. The derivative of y is 1 dy dx. Our variable is y, we're taking the derivative with respect to x. So we take the product rule, so we would have 5x times 1 times dy dx plus 5y dx dx. Now let's come back to this problem. Find the derivative. So the derivative of x squared is 2x dx dx. Then the derivative of our product that we've already taken. Now let's reduce. We should know that dx over dx is the same as 1. We want to solve for dy dx, and so we're going to get those two terms on one side of the equal sign. And move the other terms that don't have that, I'm going to move that to the right, so we make it negative. Since we're now solving for dy dx, we need to factor this out. So let's factor out our dy dx term. And now, in order to solve for dy dx, we just need to divide both sides by 5x plus 2y. An ugly answer, but not difficult. You just have to recognize the fact if you've got two variables multiplied together with implicit differentiation, you're going to have to use the product rule.
Here we have two product rules. We have that one and that one. All right, so if you need to kind of break it down into parts, we can do this one first. So this is going to be 2x dx dx, right? And then we could take the 2xy squared. We could take the negative of 2xy squared. I think that's what I'm going to do. So I won't lose that negative. All right, again, you can use u and v again. A and b doesn't really matter. All right, and then of course the derivative of 5 is 0. So let's see, here we'll take that together. Now I'm going to go ahead and do it here. That's going to be 1, so I'm going to take that product and come over to the next one. That's going to be a minus. Let's see, that's going to be 1. All right, and we have the derivative of 5, which is 0. All right, so these two terms are not alike, but they both have a dy dx. These two terms are not alike, but they don't have a dy dx. Let's go back to these two that have a dy dx. I'm going to take that out, and then the other two terms that don't have a dy dx, I'm going to move those to the other side. So this one's going to become positive, and that one's become negative. It doesn't matter which order you write them in. And then I'm going to divide. Let's see, I noticed that they all have a y in common, so I could reduce that. Let's see, do they all have an x? No. So if I wanted to reduce out a y, let's see, that would leave me 2y minus 2xy squared. That's 3x squared y minus 4x. However, I would have taken this answer. This answer is a little bit better. Right, so now let's look at some fractional exponents. This problem's actually easier, right? It's just reminding us of how you do fractional exponents, which is the same as you do not fractional exponents, right? So we have the power rule. We're going to subtract 1 from 2/3, and that's going to make it negative 1/3. So the same process. That's going to be 1. I'm going to move that to the other side. Then I'm going to divide both sides. And of course, that reduces out, thank goodness. And I have this. Now that's an okay answer, but let's go one more step and get rid of those negative exponents. And so since they're both negative, they're just going to flip-flop. So that's going to come up. That one's going to go down. So that's quite an acceptable answer. And that's how I would leave it since my original problem had fractional exponents. But I do want you to remember that a 1/3 power is the same as the cube root. All right, so now we have a fractional exponent, but notice it's around a parentheses. So we're going to have to use that chain rule. That's going to get kind of interesting. So let's see. We bring down the power. We subtract 1 from that power, and that's negative 2/3. But now I have to take the derivative of that part with respect to x. All right, so I have 2 dx dx plus 3 dy dx. equals 2x dx dx. Right, so that's going to be 1s. So this is what I've got to solve for. That's what I've got to get by itself. How about let's multiply both sides by 3. Let's start easy steps. Okay, that looks a little bit better. I think the next thing I could do would be to divide both sides by this quantity. And before I go any further, again, just like the last example, since we have a negative exponent in the bottom, we can put that to the top to make it positive. So let's go ahead and do that. So that's looking a little better. Okay, keep in mind we're trying to isolate this. All right, so it looks like to me the next algebra step would be to subtract 2. So I'm just going to subtract 2. And then the last step, since this is 3 times that, would be to divide by 3. All divided by 3. And I don't see any other way to write that answer, so I'm going to leave it just like that. Okay, this example is going to remind us again about exponents, that since I don't want to use the quotient rule, since I have a constant on top, I'm going to rewrite this with negative exponents, and then take the derivative. And then the same process, I will isolate the dy dx. So I'm going to move the 8, this term, to the other side so it becomes positive. And remember that's 1. And then I'm going to divide both sides. And then of course that reduces, don't miss that. And then I'm going to flip-flop the signs. I'm flip-flop the exponents. So the y cube's going to come up and the x cube's going to go down. And again, don't lose that negative. So really a little bit easier. Right, so now I've got a square root. Remember, a square root is a half power. And notice I'm going to have to use the product rule. I could use the chain rule, lots of different things. Let's go ahead and write this like that. And then use the product rule. So I'm going to have, okay, so using the product rule, I've got those multiplied together. And that's going to be 1. I'll multiply that together. I'm going to come up here to the rest of the problem and take the derivative. Okay, and I know that is 1. So let's see, where have I got dy dx? I've got dy dx here and here. So I need to get those on one side of the equal sign and everything else that doesn't have it on the other. So I think I'm going to keep them on the left-hand side. Means I got to move that. Okay, so again, since both of these terms have a dy dx, you need to factor that out. And then the last step would be to divide both sides by that. That is a final answer, and I am sure there's lots of algebra to simplify that, but I'm just going to leave it as is. Okay, the other parts of your homework involve you doing the same thing we've done on several assignments, as in we're going to take the derivative and use that derivative to find an equation of the tangent line. All right, so every time you're going to see find an equation of a tangent line, that means you've got to find the slope, and the slope is the derivative, which is dy dx. All right, in fact, dy dx is the change in y over the change in x, which by definition is the slope of a line. All right, so we're going to use implicit differentiation. All right, so that is my slope, the general slope of that function. Now we need to do it at that point. All right, so the slope is going to be x, which is 2, over y, which is 2 square roots of 5. You can rationalize that or not. I think I'm just going to leave it as 1 over the square root of 5. Okay, so that's my slope. So my slope is 1 over the square root of 5, and my point is 2 and 2 square roots of 5. So I'm going to use that point slope form that we've used many times. Then I'm going to multiply everything by the square root of 5. Okay, so let's be careful here. If I multiply everything by the square root of 5, and I multiply that, that's 5 times 2, which is 10. And the square root of 5's cancel on the other side. And there is your equation of the tangent line. So you're asked to do it again, just with a more complicated function. So notice we've got the product rule twice. All right, so let's see if we can do that without writing it all down. Let's be brave. Okay, so we're going to take this one. So remember, the product rule is the first times the derivative of the second plus the second times the derivative of the first. Really helps if you say it. All right, so the first times the derivative of the second plus the second times the derivative of the first. All right, now I'm going to go to the next one, so that's just minus 2y dy dx. Now we're to this one, that's also a product. So let's say it again. The first times the derivative of the second plus the second times the derivative of the first. Then the derivative of 1 is 0, and the derivative of 0 is 0. All right, so now I'm going to go through all the dx's. And so now we've got, look at all these terms that have a dx dy. 1, 2, 3. So all of those are going to stay. The rest are going to move to the other side. So let's write this a little bit prettier. Okay, I'm going to go ahead and factor out the dx dy's. Okay, so everything I underlined kind of in this gold color had a dy dx. So I factored that out in front and then left the rest of it. All right, all the other terms I'm going to move to the other side, so I'm going to have to do a negative. This term, I believe. So since those were both positive, I'm going to move those to the other side. All right, so I've got dy dx equals that beautiful expression. Now the nice thing is they've given us a nice easy point of 1, 1. So we let x be 1 and y be 1. And when of course you square or cube 1, you're still going to get 1. So the slope of my line is negative 3/2. The point is 1, 1, and that is pretty easy. So I would encourage you to get used to the product rule and see if you can just say it and write it down. You can always go back to the way we've been doing it, and that's fine. Just trying to save you a little bit of time. There would be that equation you're searching for.